So my name is PJ Kirner. I'm the CTO and one of the co-founders of Illumio. There's the second part of this session is a lot of deep dive in all the technical details, but I'm going to start by giving you the overview. I'm going to start by telling you why we do what we do and why it's important. So I'll talk about, again, as I sort of said, some of the founding insights, like the rise of the importance of lateral movement as a security concept, right? And our fundamental approach to doing this and why it's different. So let's go here. So as an entrepreneur and as a CTO, one thing that you really have to understand is what are the technical trends that are happening in the industry. Right? So the three trends that drove the creation of Illumio are the following. So one is the rise of dynamic compute, right? The compute used to be, bare metal servers, rolled in on racks. Took like 6 months, 12 months to sort of get things, set up. You had VMware come with virtualization. All right, so compute faster. You have Amazon, who with a credit card you could spin up large compute farms if you wanted, and you wanted to pay for it. And then there's the rise of containers, where containers can be very close to ephemeral workloads. So the pace and rate of compute is increasing, and it's not getting any slower, right? Number two is what I call the rise of distributed systems. But fundamentally, again, if you sort of think the history, applications used to be installed on one server. You had the rise of the three-tier applications, and then you had what is microservices, right? And if any of you have sort of seen the Netflix, microservice architecture, if you've seen that map, it is a large web of interconnected services, right? And all of our customers, whether they say they're adopting microservices or not, things are getting more and more interconnected. Whether you want to call that the API culture or call it microservices, things are happening. And what that has led to, right? That trend has led to people having larger, flatter networks because things need to actually, communicate. All right, and what happens is when you have those large, flat networks, there's the security risk that is rising, and that's the acknowledgement that lateral movement is an important security risk. If you sort of think about it, a long time ago, we spent a lot of time on intrusions, right? The whole focus was on things coming in and sort of preventing that breach. And then there was a year, I remember, DLP was the big thing. It was all about exfiltration, right? But now, people have sort of solved those problems in some way. And now what we sort of see is lateral movement. Once you have a breach, right? So what happens? What do those attackers do inside those data centers? And there's a lot of discovery that happens to sort of find those critical assets, and that's a critical thing. You can also see that in for the cyber kill chain has evolved in the sense that MITRE has put out the attack framework, and if hopefully you're all familiar with the attack framework, if not, go look it up. But what they have is 11 techniques and tactics, right? That attackers use to achieve their goals. And one of those is that lateral movement. So there's a focus on this, right? So Illumio sort of started out of, if those things exist, what does a security solution need to be to work in a dynamic, very distributed environment to solve that lateral movement problem, right? And again, a simple metaphor, about lateral movement, and a way to sort of think about this is, when they build submarines, they do not build submarines like on the left, right? They build submarines with bulkheads and compartments, right? And why do they do that, right? Because the submarine designers assume breach, right? So they need to design a reliable system, right, that can survive that breach. So if there was a breach in the submarine on the left, the entire sub fills up, right, and sinks, right? If there is a breach with a submarine that has compartments and bulkheads, right, is segmented, right, you can survive this. They build these with redundancies, right? So you lose one compartment, right? Maybe you have, you lose one machine room or a kitchen or some, sleeping beds. You have other places to sort of go to survive. This is a survivable architecture, right? And this is how we have to sort of build data centers, right? With segmentation in mind. Right. So the other interesting thing that's been happening is we've seen multiple different approaches to do segmentation. Right. And I'm going to talk about three. So the most traditional way of doing it, I'll say, is with firewalls. Right. I mean, if you sort of think about the first segmentation, it was inside and outside. There was the perimeter, right? And then you had DMZs, and you just put firewalls in place to sort of create some very coarse-grained segments. So that's one approach. You've seen the rise of what I'll call, SDN-based segmentation, right? That people can do it in the network. People can do it with a virtualized environment, but they're still using a network constructs and some of that network automation to be able to achieve that. And we sort of believe there is a third approach, which is the segment at the workload. Move the segmentation control very close as possible to the workload itself, right? So it can be dynamic, so it can be fully distributed, so you have full coverage. And so those are three approaches that exist. Why do we think ours is the most? Why do we think ours is the most important? So the first thing to realize also is segmentation is hard, right? There are some challenges when you're doing these projects, right? These are three common challenges. One challenge is you just don't have the visibility. Right? You can't just drop a new firewall in place in blocking mode inside the environment. Things are just going to break, right? Unless you have the visibility ahead of time, you can't accomplish these things. Second problem is heterogeneous environments, right? People are not going to more and more uniform, environments. People have on-prem data centers. Maybe they have colos. They have public cloud. We have people who are doing multi-cloud, right? And sometimes multi-cloud is a choice. Sometimes multi-cloud is actually forced upon you. For example, through acquisition is a commonplace. We work with a lot of large enterprises, and they acquire things. So maybe you decided you were all going to be in Amazon, and you just acquired a company, and they decided in Azure. Now, as a CISO or IT professional, you have to solve these problems for a heterogeneous environment. So this is another thing that's not getting simpler for security professionals. And the third thing is if you leverage traditional kind of networking approach, IP address-based approach, you can end up with complex, brittle security policies. So we've had places where people have attempted to do these with firewalls and had 40,000 firewall rules to achieve a segmentation goal. Being able to replace that with a higher level construct, a higher level policy model, allows you to sort of do the same thing. And I'll explain how we do it, and we will show you how they sort of do it in much smaller set of rules. We were able to achieve for that one customer. We were able to achieve that with under 50 Illumio policies, right, to achieve that same segmentation goal. So being able to abstract away from the network is important to actually solve the complexity problem. All right, so these are why things are getting harder. Right, so what is our approach? I'm going to use another metaphor here. So if you think about highways, right, for a second, and you'll say a network is kind of like a highway, right? What you really want from a highway system is fast, flexible, any-to-any connectivity. Same as what you want for your network, right? You want to be able to get the people to work, where they need to go, get them home to their kids when they get. It is important to sort of deliver, that kind of reliable connectivity. Now, on the other hand, if you think about isolation and segmentation, that's like putting the toll booths in the system. Right, and like these two things compete against each other. The more toll booths you have, the more slow you're going to get to. I mean, you've been on the bridges. You've all sat in the backup behind the toll booth. Like this is not a good way to help people with the primary goal of getting to where they need to go. So these two things are competing, right? And if you think so, how did this get solved in the highway system? Well, what did we do? We actually innovated there, right? And what we did was we decoupled. People put transponders in the devices and receivers above the highway system, right? This allowed you to drive at full speed through those stations, still get the revenue that the highway systems, and still be able to deliver on the goal of getting people where they needed to go in a fast and flexible way. right? So this is a concept of decoupling. Now, we take the same approach, right? Illumio take the same approach to decoupling here between what the network, what the network does and how we sort of implement security segmentation. And we believe a fundamental architectural shift is needed to sort of accomplish this and break these two things. Do security segmentation decoupled from the network and let the network do what it was designed to do, to be reliable, transport, right? And find a security solution that allows you to reliably isolate things. And this architectural shift is critical to success of these goals and to eliminate some of those challenges. So just last thing, so how did we accomplish this from an architectural point of view? And so there's a few concepts I want to sort of put up here, and we'll be repeating these. But first is you have workloads, right? You have workloads wherever they exist. Workloads in the data center, workloads in the cloud, workloads in containers, and so on. We have, part of our solution is what we call a virtual enforcement node, and we had a customer who sort of likened this to an antenna. So we kind of use that metaphor. These things are installed in all the operating system instances, across all those environments. The first thing that they do, right, is they send context, and this is the antenna-like. They send context and telemetry. Right? They send port information, process information, flow information up to their second part of their solution, which is the policy compute engine. And the first thing that it does, right, is builds a map. And in a few minutes, you're going to see lots of pictures of how maps are built and how we have different visualizations and different views of that map to sort of see what's going on in that environment. But you have, when you follow this point, you have a instrumentation point collecting all that data from everywhere. What happens next, right? So then you have what I call a plain language policy. And again, we'll sort of see that in a few minutes as well in terms of what some real examples are. But you just really want to say, my web servers can talk to my app servers. My app servers can talk to my database servers for this application. You want to describe it like that. And we as human beings don't sit around and necessarily talk about IP addresses all day long. We talk about it in those kind of terms. Why don't you have a policy model that takes those kind of concepts? Right? And that's what our policy compute engine does. And what it does is calculates all the necessary instructions to sort of implement that high-level security policy and pushes them back down to those VENs. And the VENs instrument the host-based controls, whether it be IP tables or Windows filtering platform or other relevant OSs that have similar kind of constructs. And this is a closed loop, right? So back to what I sort of said about one of the challenges of being dynamic. Right? So when these things change, right? When you deploy new servers, where you have an auto scale group, where new containers come online, well, that information is sort of sent to the policy compute engine. The policy compute engine understands how things are connected. It builds a graph of things, understands how things are connected. It then recomputes, without involving a human being, right, the necessary instructions to maintain that security policy that you built, right? And this continues. This continues, forever as those environments sort of evolve. And then the last part is so how do you understand risk of your environment? And one way you understand risk of your environment is around vulnerabilities, right? So we have another thing the policy compute engine could do is it can import, Qualys, Tenable, Rapid7, or other vulnerability scanners into that PC, and it builds what we call is a vulnerability map. So it takes our mapping capabilities, right, overlays the vulnerabilities on top of that. And what that helps you understand, first of all, is in context, right? Not just, this is a CVSS, 9.3, but in context, do you have any compensating controls that you might have done by, segmentation? Is this a broadly exposed vulnerability, or is this limited to just one other host can get to it based on a segmentation policy? This gives you a risk-adjusted view of vulnerabilities, and also gives you a way to sort of to provide segmentation as a compensating control to some of those vulnerabilities without having to patch, because sometimes patching is hard. So this is our fundamental solution to solving the segmentation problem at all levels of granularity that is decoupled from the environment.
The vulnerability scanners you have there, and I'm sorry if I missed that, Are you saying, is that a feed that you're then delivering into your product, or is that from one that we would already have?
No, it's from one. So if you have if you probably have a vulnerability management system, or you have a vulnerability practice, right? They might even be rescoring those things. Those can be fed into the PC. Then we give you the additional.
So you're syncing with my own, and then I can add more functionality into your product.
Absolutely. Right, and we give you that visibility. So back to like the simple example is a single vulnerability that might be exposed to everywhere in the data center, right? Versus a vulnerability that might be exposed to only 2 other workloads because you have segmented your environment. Those might be the same CVSS scores, but those have 2 different kind of risk profiles, right? So we provide that concept of risk profile to you to make better vulnerability management decisions.
So let's say I'm using one of those, and I detect 7,000 different issues. You also then say, I've already, because of the microsegmentation you guys do and everything else you do, you've already mitigated 6,500 of them.
Yes, we can tell those that have been mitigated are sort of don't sort of show up in the environment. The ones that are not mitigated, and how we have a vulnerability exposure score, right? That is the score in which we sort of help you understand risk. The ones that have been mitigated, the vulnerability exposure score is basically 0.
Well, I would say it would actually be higher than 0, because it's still a vulnerability that if someone never changed the mitigation because of policy and did something wrong, I still would want to mitigate those at some point in time, but they're not as crucial to mitigate today versus tomorrow.
Absolutely, agreed.
Do you, in that, just kind of related to that, do you have the opportunity to have like a compliance person have access to the system, but only unlimited in the exceptions or?
Absolutely. So compliance is there are a lot of these segmentation projects are done through compliance drivers. Yeah. Whether it be SWIFT or PCI or some other kind of governmental sort of control. But yes, being able to have that, and we'll show you a little bit about how we do RBAC, because that's actually an investment we made. And we'll show you why it's so important to sort of be able to do and understand that you have those.
So do you?
Sorry.
Go on.
No, you can.
Do you have reporting on things that aren't mitigated? I'm assuming you do. And then things that you have mitigated but are still a problem?
Yes.
Okay.
My question was around the reporting. Do you have a way to do like customized dashboards and monthly automated reporting that I can design for like senior leadership of the board, but also technical ones?
So, Matt, do you want to? One is we have a Splunk integration, and I think we'll sort of show that a little. What?
She's a Splunk architect.
Okay. Because one thing is, back to, we believe that we need to sort of feed all our data. Like people can do other interesting things with our data. We have other customers who are using a lot of this flow data to do lateral movement detection projects, right, and do alerting on those systems. So feeding the data to other systems and allowing those to do what they need to do is.
Lovely. Okay.
So you have those 3 integrations that you have.
Yes.
So you pulled, but do you have any others that aren't listed on this slide that in the vulnerability?
In vulnerability.
So, sorry, I'm Matthew Glenn. I run product management for the company. The technical marketing engineers who are going to be doing a bunch of the demos today are, we'll get to them in a moment. The import of the vulnerabilities is just via an API, right? So we have automatic import tools for those major scanners. Those are the ones that our customers primarily use. But if you're using like a Kirner or something like that, you can actually take those feeds and feed them into our API also. So we're not religious like only these 3 vendors. What we do is when a customer says, oh, I have this specific scanner, we import those things because it's just done via our REST API. Okay. You'll see some other integrations as our demo goes on today. As PJ said, we don't believe that we're sitting alone in the universe of security. So you'll see us integrating with like ServiceNow during the demo. We might see like other types of integrations. Splunk, you can go to Splunk Base and see our Splunk app in Splunk Base. So we understand that we have to fit within a broader ecosystem. The idea of the vulnerability management came from, we could have done, you have these packages installed on these hosts, and therefore you have this vulnerability. But when we spoke to our customers, we realized that they have vulnerability management teams. They're rescoring those. Vulnerability management is not just about saying there's a vulnerability, but it's also the management of those and sending out to the teams, hey, you need to patch that. That's a whole process. That's not is part of a whole practice inside of organizations, which is why we decided we would just fit within that practice. The same way that we're not going to sit outside of Splunk, we need to feed Splunk. So that was sort of philosophically why we do a lot of things.